what's the, oh, you missed all that stuff over there. That's too bad for you. What's the inverse cosine of 8 over this business? Yeah, you can either do radians or degrees. Sometimes I'll be specific and sometimes I won't care because they're both valid units. Which one of those units is the true physical unit? Radians or degrees? Radians. Degrees are completely freaking made up. You guys understand? You take a circle. Why did we have to cut it in 360 pieces? We didn't have to. So why did we choose 360? How many days in a year? Interesting. So we actually stole it from the Babylonians. It's also 360 has a lot of divisors, right? We're not going to choose 359. That would be remarkably dumb because there's not a lot of things that go into 359. But 360 we get pi over 3, pi over 4, pi over 2, pi over 6, and they all make sense. Cool. Pi over 7, we just 7's a crappy number anyway. Okay, so we just all right. We don't know what that is, but that's great. So what? I'm sorry. Who did radians? Anybody do who did degrees? Yes.
62.18.
62.18.
0.19 if you're right.
19 if you round it correctly.
Yep.
All right. I like that. You get the option. When we close is this, when we radians this. Radians would be, anybody did radians? Just not, I thought I heard somebody say radians.
1.09.
1.09? Yeah. And again, that's just the choice on your calculator, which mode you want to have it in. By default, what mode do you think you should have it in? Radians, hell yeah, because radians make sense in trig functions and outside of trig functions because they are an actual physical unit of measure. Degrees really only make sense inside of trig functions, to be completely honest. Okay, that's, oh my god, that's freaking useful as hell. So it doesn't matter how many dimensions my vectors live in for this process. Do you realize it doesn't matter worth shit? So why should that make sense? Any two vectors, they can be in 80 dimensions. Well, let's just talk about 3 dimensions for right now. So let's say I have a vector there and a vector there. They live in 3 dimensions, right? Because they're in the room with us. You with me? But I can look at them as if they are in 2. Any 2 vectors that aren't lying in the same direction define a plane. You with me? So that's why the process doesn't care, because effectively every 2 vectors are in a plane unless they are lying in the same direction. Okay, I like it. Maybe. Maybe. Okay. Let's see. Oh, all right. So let's do some. Let's investigate what else we can do with dot product. Then we'll talk about cross product a little bit, and then I got a handout that I want you to work on. Just use that whole board there. That was my original intent. Blah, 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 blah. Blah, 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 blah. Oh, so real quick, what does this? Now let me be more specific here. I got to be careful. I only told one possibility for this. There are 3 possibilities for why this would be true. One of them we already discussed. The 2 vectors are orthogonal. So 1, A is orthogonal to B. 2 and 3 are related to each other. What's the other 2 situations? What's called trivial solutions. How do you make a product become 0 if one of the things is itself 0, right? So if A was 0 or B was 0, wouldn't this be true? No matter how they're, because at that point, the angle between 0 and something, not really defined. Okay, maybe. Or it's overly defined, it could be everything. Okay, I just want to say that real quick, in case it comes up. So I think somebody already used this word, if I'm not mistaken, but the idea of projection. And so the idea of a projection, it kind of is a nice word for this, because just to show you the simplest visual example, because the math doesn't care if it's not this nice. This could be pointing that way for the math, whatever. But this is a nice one to do for a visual first example. So if I want to know the projection of A on B, let's talk about notation really quick. If I want the projection of A on B, in the notation, should A be higher or should B be higher if I want the projection of A on B? A should be higher. I want it on B. So the way to write the projection of A on B is projection of A on B. That's a little evil because you sort of would read it as you see it, but that's the projection of A on B. And what would that be? So the idea is if I shone a flashlight perpendicular to B, what would A's shadow look like? That's really what it is. So if I shone a flashlight, it's got to be orthogonal to B. It's got to be perpendicular to B. So it's just coming straight down in this case because that's straight across. The shadow, of course, would be that. So this vector here is this. So what direction is that line in? The direction of what? What direction is that vector lying in? The direction of B. I love it. Do you guys see that? I like it. Doesn't even have to be the x-axis because I don't know. There's no coordinate system here. Don't tell me x because here's a coordinate system. Maybe. Here's x. I don't know what the coordinate. But it's the B defines the direction. That's where the answer is in the direction of B. Which should tell you what? When you hear in the direction of B, what might you want to construct at some point in terms of B? That is pure direction. Unit vector. I like it. So what's the unit vector in B's direction? What's the unit vector in B's direction? What's the length supposed to be for a unit vector? 1. Does B necessarily have a length of 1? So whatever the length is, I want to do what with it to make it 1? Divide by it, of course. If it's length 1/2, I divide by 1/2 and just multiply by 2. Now it's length 1. Length 7, divide by 7, now it's length 1. So a unit vector in B's direction will be B divided by the length of B. I like it. That's going to come up over and over because that's the easiest way to give it a vector to define the direction only. So there's no length influence. Now how long is this going to be? That's something we should kind of already know. How long would this be? No. If I just took A and rotated it down, wouldn't that be further out? Then the shadow would be. This again sounds a lot like trigonometry, right? We've already done this. How long is this? Well, let me give you the angle. I mean, you always have this angle between the two, right? So how long will this be?
The x component.
I like it. So the length, which is called the component of A along B. Become a thingamajig. There you go. That's the component of A along B. Where have we heard the word components before? If I break a vector down into components, it's normally the component along the x-axis, component along the y-axis. This is a more general idea, component of a vector along any other vector. I can break it up into that specific direction. So what's that going to be? A cosine. All right, let me let that sink in for a second. So now, what two things do I need to define a vector? What two things do I need to define a vector? I need a direction and a length. We have a direction and we have a length. So normally I would take, if I had a direction I wanted to go in, let's say in the direction W, I would multiply by how long I want it to be, and that would be my answer. So what's the direction that I want this? The projection is going to be, what was this again? A on B yet? The length is this guy. Where do you go? A cosine theta. And the direction, so the length is just that. That's the length. And the direction is going to be this unit vector that we created. I like it. So there are a couple different ways to write this. We're going to come up with a standard way to write this, but it's not the only way to write it. What is this almost equal to? What's it missing to be equal to something we just talked about? Yeah, so if I did this, I can multiply top and bottom by b. Is that cool? Isn't that the same thing that's here? Okay, cool. And of course, this is just sitting there saying, what the hell are you doing? I'm going to just sit there for a second. Is everybody with me? Because now I could write it in terms of dot product, right? So the top of this would be what's the top here now? A dot B over B times B over B. And very often you'll see this as A dot B over B squared B. All right, let that sink in. Oh shit. So when you take a dot product, the result is always what kind of thing? Scalar. It's a number, right? When you take a dot product, it's all about lengths, right? So dot products are scalar, also called scalar products. Cross products are called vector products because their output will be a vector. All right. So, where am I at? Oh, so this is a number. What's this? That's a number. That's a number. You with me? That's the length of b squared. That's the number. Times a vector. That's just a scalar product of a vector. So that's the direction I want to be in, and that's the number that I'm going to multiply so it comes out to be the right length. Now, I slightly prefer this formulation because now you can see that's pure direction and that's pure length. But obviously it comes out to be that too computationally. Oh, shit. Yes, ma'am.
I have a question on notation.
Sure.
So when you have like the projection equals the vector A times cosine theta, right? How come it?
Well, the length of A, right?
Well, yeah, but don't you have the little like?
Sure. Oh, yeah. Well, the length of vector A.
Yeah, and then that just gets changed to the length of AB cosine theta divided by length of B.
Oh, I'm sorry.
Yeah.
Little things like that. Yep.
Okay,
Cool.
so those do need to be there.
So those got to be everywhere. Blah 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 blah. Cool. I like it. Blah 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 blah. Cool. Thank you. All right. Cool. Everybody else okay? So feel free to correct me in my notation. If I'm going to be an ass and correct you on notation, feel free to do it to me too. I'm a little more interested in the idea of this right now, but you're right. That's exactly right. You should have a little vector notation on it. Hopefully the idea makes sense. And I like this too because right here, this is the component of A along B. So some of the questions will ask you about the components. Most of them should ask you about the projection, which is the whole thing slapped together. So a component output will be what type of thing? Scalar. I love it. And of course, projection will be a vector. I like it. I like it. Okay. Blah, blah, blah. Hey, cool. We're done with that piece of paper. All right. So let me see. Maybe I can shut up for a minute. Yeah, that would be a good idea. Everybody here would appreciate that. Let me do this.